Hi viewers, in this session I am going to explain the Pelton wheel turbine. So we will see that first what is a Pelton wheel. So it is invented by some American engineer Pelton. This turbine, if you are taking this convert this energy kinetic energy. Okay, so here the energy at inlet will be a kinetic energy. Okay, so there will be the high velocity jet which is issuing from the nozzle and then strike the series of buckets which is around the wheel. Okay, so here this is the high head turbine which works. Okay, and we will see that the main components of the turbine. So this is the penstock. This penstock is it is from the reservoir. Okay, the water from the reservoir will get into this penstock, and there will be a nozzle will be there. So this nozzle here you can the spear is there. By means of the spear we can adjust the speed of water which is enter into this nozzle. Okay, so when if you are increasing, the pressure will be increased, and there will be a the casing will be there. There will be a steel casing will be there. So whenever the water is coming from this nozzle, it will not allow the water which is uh, spread around the place. Okay, and here there will be the number of buckets are placed in this manner, and there will be a braking jet and also the runner. Okay, so now we will see the things one by one. The first one is a penstock. So this is a large concrete pipe. If you are taking that, the diameter of the concrete pipe will be somewhat huge, since the more amount of water will be coming from that reservoir to the turbine, then only the speed of the turbine, that is a runner, will be increased. Then only we can get more mechanical energy. So this is mainly this is made up of the concrete, and this will convey the water from high level of the reservoir to the turbine. And the next one is a spear. So this is the here we are using the nozzle to convert this hydraulic energy into the kinetic energy, and here this the spear is arranged. It will move forward and backward direction to increase the area of the nozzle passage. Okay, and the next one is the casing. So here the casing is preventing the splashing of water throughout that area, and which scatter in all direction and to guide the water to the tail base. And the next one is a runner with the buckets. So this is a runner and this is a buckets. Whenever this turbine, that is a runner, rotates, this is a circular disc which is carrying the number of this cups we are calling that as a bucket, and it is fixed around the periphery of the disc. So you can see this how this it is fixed by means of the bolts. So this is a runner, and the buckets you can see this this is a split buckets, and this is a nozzle, and this is a spear. Whenever the water which is coming here, if you want to reduce that the nozzle diameter, which can be carried out by the spear. Okay, so once the water is open to the penstock, and here the spear is moving from inward and outward direction, the water will be splashing into the bucket and it will start rotate. So this due to this rotation of the water, here the hydraulic energy is converted into the mechanical energy. So next, if you are taking that braking jet, so this is to provider to stop the runner in short time. Okay, so here this is a small nozzle which directs the jet of water on the back of the vanes. So whenever the vanes are like this, the water which is placed, the jet of braking jet is placed here. This will stop the water rotation. Okay, so this jet of water is called a braking of jet. And the next one, if you are taking this is a spear, and you can see that how the water is coming the thing. So there are two numbers of nozzles are placed, and this is a bucket, and so this is a wheel or runner. So there will be shaft will be there. So here mostly we are providing the nozzle. It may be a one. mostly we are providing the one, some cases we are providing the more than one to produce the more power. And this here if you are taking this, the nozzles are placed spaced eventually around the same runner. So if you are taking that theoretically, if you are taking that the Pelton wheel turbine, 6 nozzles can be provided. And if you are taking that the number of jets, so there will be a the limit is not more than the 2 jets per runner of the vertical runner. Okay, so it should not be more than not 4 per runner. And if you are taking that number of buckets, this is a calculation which is used for deciding the number of buckets around the runner. So it will be a 15 plus capital D divided by 2 into small d. So the capital D will be the shaft diameter. And if you are taking that to get the discharge and to get the efficiency of the water, we have to know about the velocity triangle. So this is the velocity triangle which is used for to find the theoretical efficiency of the turbine theoretically. So if you are taking the efficiency, so there is a overall efficiency, hydraulic efficiency, volumetric efficiency, and mechanical energy. In generally, the efficiency is nothing but output by input into the 100. Okay. So if you want to get the overall efficiency, it is nothing but the ratio between power at available at turbine shaft and to the power available from the water jet. And if I am talking about that hydraulic efficiency, it is a ratio between work done per second to the kinetic energy per second. And if you are going to the volumetric efficiency, so this is the ratio between water which is actually striking the bucket to the total water supplied to the jet. And the last one is the mechanical efficiency. This is nothing but ratio between shaft power to the water power. So from this video, you can understand that what is a Pelton wheel turbine, and as a best example for the impulse turbine, what are the components, how it is working, how you can get the efficiency of the Pelton wheel turbine. So thank you for listening this video. Thank you.